This was a dream come true for I think a lot of hail scientists. It was 5+ years in the making. And the data that's been collected has just been nothing short of amazing. Everywhere from all the radar data, we've got over 0.5 terabyte of just raw distrometer data alone. You guys get going and get out of here. We've got shingle panels, we got all the wind sondes, hail sondes. We have potentially record measured thunderstorm updrafts in this data set. This is going to represent a giant leap forward in hail science.
I've had such a great experience being out here and learning more from industry experts, and doing this type of campaign has actually been an awesome experience.
So we started in South Carolina at the lab. We drove out to Colorado. I think on that first day we went through 6 or 7 states. Pretty much seen everything east of the Rockies. We're here finishing off in Dodge City. I almost felt like we started in Dodge City, so it's come full circle here for the Kansas tour.
Once we split though, stick with ground 2. We'll be with the whole fleet for a little while.
Good call, thanks IBHS 1.
Across the ground teams, we had 14 individual vehicles all deploying different types of instruments. So yes, at IBHS we had our impact distrometers. We had the Purdue and National Severe Storms Laboratory team deploying Parseval distrometers. Those are distrometers that measure raindrop size distributions as well as small hail. Those are also equipped with thermodynamic measurements like temperature, humidity, pressure, and wind data. We also had the tornado pods from the farm group at Alabama Huntsville. Those measure wind speed at about 1 meter height. They also have temperature, humidity, pressure on them as well. And those are just some of the flavors of instruments. And then I'll rewind it back. The old school original hail pad deployed by the Central Michigan teams still has its place, still does great work. And I think we have deployed thousands of hail pads over the 6 weeks of ICECHIP. Don't even know the number off the top of my head. It's too big to count right now. But that's just the spectrum of all the ground instruments that we had going for the ICECHIP project.
But ICECHIP was able to incorporate air observations with UAS. We had also our ground observations, but also having mobile radars available to us, and soundings as well. So all of that combined, we're able to kind of see the storm as a whole and how it progresses versus just seeing what's on the ground.
So the lead up to this, it was a lot of testing, a lot of calibrations, a lot of reworks on the instruments and code fixes, hardware fixes. But we got it done, and out here the instruments have held up very well. We've had a few that we've actually flooded in rivers almost, and they held up fine. So the circuit boards and the wiring, all that we have, we protected it well, and the materials, they've held up well, and I'm excited for it. It's made me happy. It's made my job out here a lot easier with the troubleshooting and all the stuff that happens that you can't foresee.
Going out day after day, going through the grind, making these observations. And it's not just about executing your plan. Everything has to work out for you. The roads have to work out. The storm has to do what you need it to do to get into those roads. And then you need to safely deploy your instruments and go make those measurements you need. 28.5, 25.1, 25.1.
I mean, we bring shingle panels out. We have been for the past 2 years or so. And it's been really cool to get the shingle panels that we have out here with us into some really large hail. We've been trying to do that for the past couple of years and haven't been successful, but we've got the F-Wave panels and a metal panel, and it's been really cool to see how the F-Wave actually does in large hail. It's really cool to see what we're doing in the lab and then bringing it out into the field and kind of helping advance the material science.
But I think from an IBHS perspective, our focus will shift a bit away from understanding the bigger picture of hail storms, but into product durability to hail. We've had extreme success deploying roofing material panels with our impact distrometers with high-speed camera systems. We have the wind-driven hail probe. Our work will then turn toward bringing those materials to the field and putting them into real environments. Why wait for the storm to come to you? We're going to take those materials to the storm and go look at this product durability. Because if we look at the picture of growing losses today, this problem is unsustainable at the dollar amounts we see. And we have got to find those materials. We have got to make those tests better to start whittling down that giant exponential growth in hail-related building losses.
I'm excited I'm just in general excited to see how this is all going to come together and what these results are going to look like when we have our sounding data and our radar data versus what we're seeing on the ground. kind of learning more that we're actually seeing more softer hailstones versus hard, which I know we do a lot of hard stone work at the lab. So I'm really interested to see how this is going to play out and how it's going to play out with our shingle ratings and how it's going to further advance what we're doing on the research side.
You know, two surprises. One is how strong thunderstorm updrafts actually may be and how chaotic they actually are. That's one of the things that the windsons and hailsons have showed us. Now, from a hailstone perspective, I think something that was surprising is seeing the amount of ductile compression stones. These are stones that when put under high loads, like 200, 300, 400 pounds of force, don't ever fracture.
Go, Artie, go.
They just compress and hold their shape. So those are fascinating. We had a few of those in our IBHS database, but we've seen quite a few out here in ICECHIP. And also filling in that strength distribution. We will end up, when you combine the ICECHIP data with our IBHS hailstone database, somewhere close to 10,000 hailstones measured and crushed. That is a very meaningful statistical data set.
18.8, 7.7.
And it's important for entities like IBHS that's helped raise the awareness of the issue and the cost of hailstorms. But we've also helped lead the way in some of the applied research and that resurgence in hail research that we've seen that led up to the ICECHIP project. You may think of these big projects as just being universities and government labs, but the private sector has that role to play, especially us at IBHS, as we look at the application of all this information that comes out of this kind of work and how we, one, can design better testing for our building materials. We can look at how do we incorporate hail into our building codes. And we have all this information to work on to make those weather products that, say, the insurance and risk industry uses every single day with severe weather better and better and better.